Hi my dear students, in this video I am going to explain about the synthesis of peptides. Synthesis of peptides is important from two standpoints. Firstly, we can prepare in the laboratory the compounds identical with the natural ones, and secondly the synthetic peptides serve useful model compounds for understanding the structural features of proteins. See, already we know that peptides are polyamides and can be synthesized by the stepwise condensation, in which the amino group of one amino acid is condensed with the carboxylic group of a second amino acid until after successive operations the desired polypeptides chain is built up. But the actual process is not so simple as it appears. It is complicated by the fact that self-condensation of the two molecules of the same amino acid appears. It may possible because of the presence of both the functionalities in each amino acid. However, this difficulty can be overcome by converting the amino group of one amino acid into substituted amino group, thus preventing it from condensation with the carboxylic group of the other. This amino group is now said to be protected or blocked from chemical reaction with carboxylic group, and condensation of carboxylic group of the protected amino acid with the amino group of a different amino acid can selectively take place alternatively. See here, the carboxylic group of one amino acid may be suitably protected so that the selective condensation of the amino group of this acid with the carboxylic group of the other acid can occur, as protection of amino or carboxylic group is necessary. So here some steps are there in the synthesis of peptide synthesis. There are three steps. One is protection of amino or carboxylic group, and second one is condensation step, and third one is removal of the protecting group. The following general sequences illustrated as below. See here, first one is peptide synthesis by protecting amino group. First we can synthesize the peptides by protecting the amino group. Here also again three steps. First one is protection of amino group of amino acid. Here what happens, by taking a suitable protecting agent, or suitable reagent, we can protect the N terminus of the peptide bond. So it can protect the N terminus of the peptide. So in the first step we protected the amino N terminus of the amino acid. Next step is a condensation of the carboxylic group of the N protected amino acid with the amino group of this second amino acid. Here what happens, the protected N group N terminus of the first amino acid, which is condensed with the another amino acid. So it undergoes condensation, means it liberated some water or some other molecules are condensed, so we will get the protected dipeptide bond. So you are observing that in between two amino acids it forms the CONH bond. In the next step, removal of the protecting group. Once the dipeptides or tripeptide bonds are formed, our aim is to remove that protecting group. So by taking suitable selecting reagents, means deblocking or deprotected reagents, we can remove the protected group by selecting such a reagents and a reaction condition that do not affect the peptide linkage. So by adding some agents to this protecting group that can remove that protected group, so we can get the only peptides at the end of the synthesis. In a similar way, in the synthesis of peptide synthesis by protecting carboxylic group, the first one is by protecting the amino group. In the second step is by protecting the carboxylic group. In the first case, in the protection of the carboxylic group of the amino acid, here also by taking by selecting suitable reagents or protecting agents, it is treated with any amino acids. It forms the C terminus of the peptide, so that will condense with the carboxylic group of this acid. So it forms the C protected amino acid, means it protected the carboxylic group of the amino acid in the first step. In the second step, it undergoes condensation of the amino group of the protected amino acid with carboxylic group of the other. So it produces mentioned under second step of the protecting amino group used to form a protected dipeptide. So once it undergoes condensation, it forms the protected dipeptide bond. In the second step, we got the protected dipeptide. Once it protected the dipeptides or tripeptide, we can remove the protecting group. Here the protecting group is removed using any of the usual methods, taking case to choose such reagents that do not affect the peptide bond or peptide chain. So by adding some reagents into this peptide synthesis at the end, so it removed the protecting agents from that peptide chain, so that we can get only the peptide chain at the end of the synthesis by removing the protecting groups without harmful or without effect to the peptide chain. So next come to the some example by taking some N-terminus protecting agent. Here acylation of the group is one of the most common methods for protecting this group. Here we are taking carbobenzoxy chloride or benzoxycarboxyl chloride as a N protecting agents. It is an ester as well as an acid chloride of carbonic acid, and it is obtained by treating benzyl alcohol with carbonic chloride. So when treated with an amino compound, it forms the corresponding substituted amide, which either on catalytic reduction or treatment with hydrobromic acid in acetic acid reagents the amino via carbamic acid. So once we prepared the benzyloxycarbonyl chloride, it acts as a N-terminus protecting agents. So this protecting agents treated with RNH2. RNH2 here nothing but one peptide R is equal to COH and CHR. So here you are observing that this benzoxyl carbonyl chloride, it protects the amino group of the RNH2, means it is protected, it forms the protected dipeptide. So it is treated with the HBr or hydrogen, so it forms the carbamic acid. Again it undergoes decomposition, it forms the RNH2. So here you are observed that benzoyl carboxyl chloride, it protected the RNH2. Here it protected the N-terminus of the amino acid, and by the decomposition we can remove the protected agents, so we get the peptides. Next one is second example is tertiary butyl oxycarbonyl compounds. Here we can take tertiary butyl oxycarbonyl chloride also, but in this example I am taking this tertiary BOC azide. This is the structure of tertiary butyl oxycarbonyl azide. So this group, it acts as a protecting agent. So it is reacts with any amino acids in the presence of TEA, means 10% triethylamine, in the presence of water about 24 hours. We will get N protected, means amino group protected peptide bond. Next one is by taking fluoronyl methoxycarbonyl group. It also acts as a protecting agent. N protecting agent means N terminus protecting agent. So again it reacts with one amino group in the presence of 10% Na2CO3. So we will get this N protected peptide bond. Next, C terminus protecting group. Esterification of the carboxylic group with benzyl alcohol is the most common method of protecting this group, or we can take methyl alcohol also we can take during the esterification to protect the carboxylic group. The ester so obtained is readily converted into the free carboxylic acid either by catalytic reduction or by hydrolysis with dilute alkali. CrCOOH. Here R is nothing but NH2CH, that is attached with one R group. R may be alkyl or aryl group. It depends on the amino acids. So it reacts with benzyl alcohol. It forms the ester. Again that ester undergoes hydrolysis or catalytic reduction. It gives the respective peptides with the removal of protecting agents. Next, here one example, synthesis of glycylalanine or glyalapeptide. So here glycine is one amino acid, alanine is one amino acid. So here we are synthesizing the glycylalanine peptide, means we are combining two amino acids in this synthesis process. The synthesis of the simple dipeptide glycylalanine illustrated the above procedure for peptide synthesis using protection of N terminus. So here in this synthesis we are taking the N terminus protecting agents, means we are protecting the N group of the one amino acid. First step is protection of amino group of glycine by treating it with carbobenzoxyl chloride, which gives N protected benzoxyglycine. Again in the second step, activation of carboxylic group of first one. So conversion into the corresponding acid chloride in the presence of thionyl chloride. So in the next step, condensation of second structure with alanine to give a carbobenzoxyglycyl alanine. So once it forms the protected dipeptide, means this carbobenzoxyl, it acts as a protecting agent. It protects the glycyl alanine bond. So it is called protected dipeptide bond. So once it reacts with alanine, so it forms the peptide bond along with the protecting agents. At the end, our aim is to remove the protecting agents by adding some suitable removal agents or deblocking agents. We can get the peptides, that is glycyl alanine peptides. Thank you.